Good morning and welcome. I'm Eric Davidson, President of the American Geophysical Union. We've had three wonderful days of meetings in which we have appreciated the latest developments in discovery and in research presented by all of our members, from senior members to students. And I think that reinforces our sense of how important our mission of discovery for the benefit of humanity is for the American Geophysical Union. Of course, at the end of each of those talks, quite frequently, you see, at least briefly, a few little logos that pop up that are often related to some funding agency, either in the United States or abroad. But today we get an opportunity to focus, at least for the United States, on the importance of some of those funding agencies and their visions for the next few years. And so I'm delighted to be able to welcome to this special session some of the high-level administrators, managers from some of our most important science funding agencies. So today's session is entitled Perspectives and Priorities on Earth and Space Science. And we will be hearing from officials at NASA, the National Science Foundation, NOAA, and USGS. Our panelists will share their views on the state of science at their agencies and their priorities for the near future. And they'll also tell us how they believe science will fare in this era of increasing budget pressures. Our panelists include Rear Admiral Tim Gallaudet, Assistant Secretary of Commerce for Oceans and Atmosphere, an acting NOAA administrator. Dennis Strusek, the Deputy Associate Administrator for NASA's Science Mission Directorate. William Easterling, Head of the National Science Foundation Directorate for Geosciences and Dean of the College of Earth and Mineral Sciences at Pennsylvania State University. And Bill Werkheiser, Acting Director of USGS, who unfortunately couldn't be with us today, but sent a recorded presentation which we will play in a few minutes. I'll be inviting all of the speakers up at the end for a brief panel discussion, but I'd like to begin now by asking you to please welcome Rear Admiral Tim Gallaudet.
Well, good morning, everybody. How are y'all doing? Come on. How is everybody doing? All right, all right. So just so you know, I gave this presentation to my entire workforce 2 Fridays ago, and it took an hour. I'm going to do it for 10 minutes for you all, though, so I hope you're happy with that. But first off, we're going to talk a bit about our accomplishments this year, and I'll weave into it what our priorities are for NOAA under the new administration. Really not so new, being in it for about almost a year. So here we go. I'll start with our satellites and data. We've launched 2 satellites this year. And that's quite something. And we don't do that every year. And both have been very successful. We have our geostationary satellite, GOES-16, and we have our polar orbiting satellite, NOAA 20, that was launched in Vandenberg. And we're going to launch our GOES-S in March. So 3 satellites within a little over a year is quite an accomplishment. And these are the state of the art, and they're absolutely essential in doing what we did this year, and that was endure $17 billion weather disasters. Most notably the hurricane season, which was a record setter in terms of energetic hurricanes and in numbers, 3 Cat 4s hitting the states. We did so well this year in predicting them because of data from our satellites and all our other integrated observing systems that include buoys, floats, drifters, ships, aircraft, and land-based sensors and radar. So that integrated observing network is really the world's best. And that is one of the goals of this administration for NOAA, and that is leading the world in our Earth observations and our predictions capability, our modeling. Data reliability on the right here, we've had also a record-setting year with 99.5% availability of all our data. You know, just about a 0.5% dropout rate across all that integrated systems I told you about. 16 ships, 9 aircraft, 400 boats, and thousands of other sensors moored or floating. And all of that we are able to push through into our modeling capability and our data portals at a 99.5% reliability, and that's quite an accomplishment. So we had a great year for satellites and data. Okay, next off, it's taking a while to get there, thank you. Weather and water, so our National Weather Service is what I'm referring to here. Yeah, as I told you, a very active season. Let me give you a statistic, which is quite impressive. In 2005, when Hurricane Katrina severely affected New Orleans and this whole region, we had one half the property damage that we saw this year in 2017. So 2017 saw twice the destruction that occurred across the U.S. and the Caribbean that we had in 2005. And I'm a first-hand witness. My house was washed away in South Diamond Head, just about an hour east of here. And so I know firsthand how the destructive power of 2005, and this year was double it. However, the loss of life compared to 2005 this year was a fifth, just over 200 people or so, which is regrettable. However, we had such a good record in terms of saving lives because of our National Weather Service being so engaged with our emergency managers. That partnership has been evolving after Hurricane Sandy, and is probably the best it's ever been. And a good anecdote that I want you to take away was when Hurricane Harvey hit Texas and just flooded the entire region, we knew this about a week in advance, and our National Weather Service predicted to local emergency managers that we would get 50 inches of rain a week in advance. Had we ever told officials and authorities that in the past, they would have laughed at us. They wouldn't even, they wouldn't have believed it. But they had such confidence in our ability to work with them and inform them and warn for them that they moved out, and they saved a lot of lives evacuating people and ensuring that those who stayed sheltered in place. We also made great advances with our national water model. Water sometimes is referred to as the new oil, and so as a resource and also as a potential hazard. And so we made great strides in our water modeling capability, and you see on the image on the upper right is the water levels predicted and observed for Hurricane Harvey, like I just mentioned. So very important data to keep our nation safe. For fleet operations, as I told you, we have a fleet of aircraft, ships. We also have 400 divers. And I was in the Navy, for 32 years, and I oversaw all of Naval Oceanography's assets, and I thought it was quite a big enterprise until I got to NOAA. Compared to NOAA, the Naval Oceanography had 10 fewer ships, had 8 fewer aircraft, had no divers, had no boats, while NOAA has about 250 divers and 400 boats. So I'm upping the game big time moving into NOAA from the Navy. You wouldn't have thought that. And here's the kicker. NOAA's customer base is about 100 times that of the Navy oceanography and meteorology community. There's about 325,000 people in the Navy who the Navy weather forecasters and oceanographers serve. There's 325 million people in the United States. That's who NOAA has served, and they've served them very well. We're recapitalizing our aircraft. You can see the operation rates for aircraft and ships there. And our divers have accomplished some amazing things in terms of research on deep sea corals. Our NOAA divers set a NOAA record on diving to 330 feet this year. If anybody's a scuba diver, they know how much of a varsity level effort that is. My wife was a Navy diver, U.S. Navy diver, and she never punched below 190 feet, and that's something else. So we have some great competent professionals in our fleet operations in NOAA. In our fisheries, we also have a great story to tell. We have rebounded 44 stocks since 2000. I just read in the paper today that the Pacific perch has rebounded too and been restored. And you see that we have a few reports, 3 on the left there, that depict some of the assessments we've conducted with regards to economic impact. And our commercial fishing enterprise in the U.S. is a $200 billion affair. That's a big economic prospect, and it creates over about 1.7 million jobs. If you want to get your arms around that number, if $200 billion, you could buy all the aircraft carriers in the Navy twice. So that's the economic contribution of NOAA Fisheries. And they're innovating rapidly. And on the right here, I show a project we undertook where we took a UAV, a drone, to survey harbor seals in Antarctica. Important effort to assess at the top of the food chain the health of the ecosystems down there. Well, the previous modus operandi of our fisheries folks was to go out on boats, haul these seals in on nets. They're leopard seals. They weren't very happy, so it gets a little difficult. And measure them, weigh them, assess their health. So it would take about 5 to 6 people, 5 to 6 hours, and be quite dangerous. Where you employ unmanned autonomous technology, and it took 2 people 20 minutes. So that's the great kind of innovation that fisheries are doing. And again, with another priority under this administration is to grow the sustainable economic contributions of our fisheries and ocean resources, with our main priority to reduce our $14 billion seafood trade deficit. And so the fisheries folks are advancing aquaculture to that end, and we're going to cut into that deficit quick. And on our oceans and coasts, as I mentioned, our charting capability and our hydrographic surveyors are doing great things to better map the seafloor in our exclusive economic zones. We have released a new national charting plan, and we also have an effort underway to conduct precision navigation surveys in our nation's ports. That's important because there's a great economic impact. For every foot you can give a container ship of draft, deeper, that's about $1 million worth of cargo or product. So if you multiply that by the number of ships in any given port and the number of ports in the U.S., that's $1 billion of extra trade you can leverage and provide the nation if we survey our ports with a higher degree of accuracy and relax the depth thresholds at different ports. We were able to do that in Los Angeles, and we're going to be doing that in several other ports, including Miami in the year to come. And then our surveyors also did great work in response to the hurricanes, because many of the ports on the south coast, Texas, Florida, had a lot of debris in them, and so we sent teams in there to resurvey all the ports so we can get in shipping. And every day that a port can't operate, it translates into hundreds of millions of dollars in lost goods and traded. So that effort was very important to the Secretary of Commerce, and we were able to move out very quickly and open all the ports up in the U.S. South Coast. Lastly, I'll talk about our research office, the Office of Atmospheric and Oceanic Research. We had two efforts underway. We had this capstone research cruise, and I show on the left here some of these new species we found. Don't ask me to name them, but that effort is interestingly, that has a very important national security contribution. And when I show this slide to my team at NOAA and talk about national security, on the left side of that screen, it was hard for them to make the connection, as you would probably understand, but here's the reason it's so important. We need to know our oceans better than the competition, especially from not only from the economic contributions that we can make by resource extraction, for example, but also in terms of defense. Some of the most critical assets we have are undersea infrastructure, including undersea cables, and those are threatened by adversaries, so we need to keep them safe, and we need to monitor them and know the nature of the seafloor and the water column to best protect them. So that capstone effort that we undertook to survey areas of the U.S. EEZ was contributing to that effort. Secondly, on the right, I've depicted our experimental model. We refer to it as the finite volume cubed, or FE3. It's our experimental weather model, and you'll see for Hurricane Harvey, basically we're outclassing the Europeans, and that's the third priority for this administration in terms of leading the world in our modeling capability and reducing the impacts of severe weather. And so you can see we're already doing that with our experimental version, which we are transitioning to operations, and then we're even looking beyond this to the next generation global forecast system. So a lot of very encouraging prospects here for NOAA moving forward. So lastly, let me just close and kind of foot stomp what I said earlier. With $17 billion disasters, wildfires, hurricanes, flooding in this country, if this happened to anybody else, any other country in the world, they'd be broken. But this year, the U.S. has increased GDP by about 3% each quarter. And that is just unbelievable. And we've done that because NOAA, in partnership with NSF and USGS and NASA, we have worked together to understand the Earth system well at a tactical scale, local and close to the coast, and at a global strategic scale. And that has allowed us to be better prepared for storms and disasters, and also to better respond to them. And that all together is what referred to as resilience. And I think it's easy to state that we are, as a nation and as a team with the other agencies represented here in this panel, global leaders in this effort. And this hurricane and storm season proved it. So thank you very much.
So next up is Dennis Andersek, the Deputy Associate Administrator for NASA's Science Mission Directorate.
Thank you. Push 3. There you go. And I advance the slides by clicking the mouse. The white keyboard. The white keyboard. Yep. Got it. Thank you. Well, good morning, everybody. My name is, as you heard, Dennis Andrusik. It's like the boy's name Andrew, who is sick. You run it together, you got Andrusik. It looks a lot worse up on the screen, but trust me, it's really, really easy. By the way, I do tell folks, just as a FYI, I do have a neurological disease. It's called Charcot-Marie tooth disease. It's related to muscular dystrophy. Doesn't matter a bit for this presentation, but if you see me shaking, I want to assure you I am not nervous or angry or upset. It's just part of the deal. So I will not pick up a laser pointer, so it will not make you sick. But anyway, here to talk about NASA science perspectives and priorities. And it's a great topic. When I first started pulling slides together for this, and by the way, thank you to the AGU for inviting us, I had a huge slide deck because there's so much that we can present and so much exciting things that are going on. And I did cut it back. It was like telling me which one of my children I like best. But these scientific missions are just fantastic. But if I get into talking about where we're headed with science, it's important to kind of frame it. We have 4 different science divisions, and one division dedicated to working with our counterpart NOAA. We have a great relationship with NOAA. In the scientific areas, we explore other planets. Of course, Earth is a planet, but exploring other planets besides Earth, within our solar system or outside. And by the way, there's a town hall on planetary science at 12:30 today. Shameless plug for those folks. Within heliophysics, studying our sun and its interaction with the Earth. There was a town hall on that on Monday evening. Studying the Earth, the solid Earth, atmospheres, oceans, and how and the interplay between them. Looking over at astrophysics, studying other stars, what they mean, how they work. How do we expand our own knowledge of those star systems? Exoplanets is also buried in there, but I'll tell you what, there's some cross-discipline areas that I'll touch on in a couple seconds. That you'll see where exoplanets are, there's interest there in astrophysics and planetary. And finally, what we call JASD, our Joint Agency Satellite Division. That is the organization that interfaces with NOAA, and we together build the polar and geosynchronous orbiting weather satellites to meet our nation's weather needs. This is how it breaks out in dollars and in activity. The overall NASA Science Mission Directorate budget is about $6 billion a year. Of that, we invest about $400 million in technology. So technology is a key push area for us. Future missions, going into space is hard. Innovation and new technology is key to achieving our goals in space exploration. As an FYI for you, that $400 million is dedicated to building new science technologies. It might be detectors, it might be optics, it might be a new model, it might be other ways that improve our science, but they're dedicated to the specific scientific areas of pursuit. There's a fellow organization within NASA called the Space Technology Mission Directorate, which has about a $680 million a year budget. They invest in the cross-cutting technologies. So if you're ever interested in look at the NASA budget and figure, why are they both doing technology? The easy answer is they're doing optical comm, they're doing power systems, they're doing the technology that apply across the board in the different pursuits that the agency has. SMD's investments are in technology specifically targeted at science. In the area of research, we fund about 10,000 scientists a year. And there are about 3,000 competitively selected awards. There can be more than one scientist on an award, so if you're wondering how that adds up, there's the math. And to the effect, about 600 million of that goes into research grants. And that's our seed corn. That represents our future. We implement that through spacecraft. And you'll actually, and in case you're wondering, what, you got 105 spacecraft and 88, or 105 missions and 88 spacecraft. How does that math add up? It's actually very simple. We want to increase our scientific return and get the greatest bang for the buck in science. So we'll build an instrument. For example, we're building a synthetic aperture radar that will fly on an Indian spacecraft. We'll build an instrument that will fly on a communication spacecraft in geosynchronous orbit. So where we can, we'll leverage another spacecraft asset, and that'll be a mission flying to the space station. Still sitting on the ground. We're hopeful that it will launch on Friday, but we have a payload called TESIS that is going to launch at the next space station resupply mission, again scheduled for Friday morning on a Falcon 9. So that's the difference between the two. I won't get into each of the others, but we also use CubeSats as ways to pioneer new capability. Sounding rockets and then suborbital missions, sounding rockets, Earth-based aircraft investigations, and balloons are all great ways to verify technology and capability in a low-cost manner. Talking about perspectives, what are some of our values? You heard Admiral Gallaudet talk about leadership. I believe that we're all leaders. The agencies work together in leadership in exploration. And NASA in particular, we work very closely with the National Academy of Science, and we have the decadal surveys that talk about the future measurements we should be making in each one of the scientific areas. We're very excited about bringing that to the community. We excel for impact. In all we do, it's the impact. It's communicating that scientific value to our stakeholders and to the public in general that is very, very important. Yesterday, at the Hyperwell, we talked about some young students. The AGU had a competition in data visualization and storytelling. It was really cool how some young college students had come up with new ways to display NASA data. So it's not just a spreadsheet or not just a PowerPoint slide, but to actually show how you can manipulate data in new and interesting ways. It was very spectacular. It's quite spectacular. Exploring is one. While we might be providing leadership, I got to tell you, space exploration is a team sport. We do it together. So while I'll be talking about NASA and a lot of these things, trust me, it's all of us and it's all of you working together. I had somebody ask me the other day, what do I think about commercial entities getting into the space business? And I think they were expecting me to say, oh, that's bad, it's going to compete with NASA. And I'll tell you what, my answer is 180 degrees out of phase with that. The more the merrier. The greater investment in the space and aerospace world, the more we can do, the more we can achieve. So I'm all excited about the commercial investments as well as the international. And I've got international coming up in just a second. And enabled by innovation, I talked about technology, and that's what that's all about. And finally, inspiring learners. Quite often we get caught up in talking about inspiring leaders. Yes, we need leaders. Don't get me wrong. We definitely need leaders. But the leaders and the next generation are key to our success, not just the leaders. We need everybody that's coming up through the aerospace business to learn, to understand what the next steps will be in making the measurements that will make our science matter to the American public and to the world. This is that portfolio I talked about on the 2 charts ago. It's broken up, not in the boring quad chart manner, but it is kind of a quad chart. In the lower left-hand side, you can see all the Earth science missions. The ones in bold are the ones that we're currently in formulation now. The ones that are not in bold are the missions that are flying. So of those 105 missions, 88 spacecraft, this is it. It's huge. It's incredible. I am really proud of this. We were talking at breakfast. Just as a personal plug, I'm eligible to retire. I'm not going anywhere. I'm having a great time. And it's because of this, and it's because of the work that everybody does that makes exploration exciting. In the lower left-hand side, you have all the Earth science missions. Upper left, astrophysics, studying distant stars. That's where the James Webb Space Telescope is, WFIRST. I could keep naming missions, but I won't, because I'll be well beyond my time. Probably already am beyond my time. In heliophysics, upper right-hand corner, studying our sun and its interactions with the Earth. In planetary, in the lower right-hand side. A great deal of knowledge is coming out of our planetary missions. I'm sad to say that the Cassini spacecraft is no longer shown here orbiting Saturn, because on September 15th, its mission ended. The mission itself, the flight mission ended, but we're still analyzing the data. So it lives on in the data side, but the mission is no longer flying. But you see Juno, you see exploring Jupiter, you see other missions up here that are still very exciting, very robust, and will carry on. Here's some of our international partners. Didn't fully, here it goes, it's populating now. I mentioned the international world. Much like the commercial world, I've been asked, are you still going to be doing international collaborations? And the answer is absolutely yes. The international community works very closely with NASA to build the systems we need tomorrow. And it's not a case where, by the way, this is a true partnership. If some people think about a contract as a partnership, that's a contract. A partnership is where we're both bringing something to the table. In all of these international partnerships, NASA's bringing something, and we insist that, the international partner brings something to the table as well. So working with the Japanese, will be on GPM, they brought the launch and the active radars to the Global Precipitation Measurement Mission. On JWST, on X-ray exploration, I can mention many, on the NISAR, I mentioned already, the synthetic aperture radar we're delivering to the Indian Space Agency. So in each one of these international collaborations, it is a true collaboration, and it's helping us achieve our goals. I see them continuing into the future. I'm going to just throw up a couple of slides here on where we are and where we're headed. This is the MSL Curiosity rover. No, we didn't put a GoPro up on a rock and have it take a picture of itself. This is actually a mosaic. The arm reached out, took several selfies, and we stitched it together. And that's how we got this image. This is a true image of MSL. It's an awesome, if you look at the shadow under the arm, it'll be a giveaway on how that took place. Other than that, the artist did a very good job. But the Mars 2020, the reason I have this is not just to talk about where we are, but where we're going. The Mars 2020 rover is almost a carbon copy of MSL, except it's got a sample collection system that will cache samples for a future, still not definite, but a future planned or hoped for Mars sample return mission. So really excited about that. There's also a payload on there called MOXIE that the human side and the technology side funded. It's going to take the Martian atmosphere, which is mostly carbon dioxide, and turn that into oxygen for a future ISRU, or in situ resource utilization. Future astronauts are going to need oxygen, but more importantly, they're going to need oxygen in the fuel systems for the return ride. Really excited about that in the future. Exploring Europa, one of the ocean worlds. It's a moon of Jupiter. Really excited about going there. Warm core, thick ocean, ice crust. We see geysers of water. If we're going to go search for life elsewhere, or signs of life elsewhere, this is our first stop. And we look forward to seeing what science will come out of this mission, and hopefully, not a done deal yet, but hopefully one of these days perhaps land there. Last February, in talking about exoplanets, it was announced the discovery of seven exoplanets in the Trappist System, and that's 40 light years away. Now, for those of you who don't speak in light years, light second is 186,000 miles per second, 3,600 seconds in an hour, 24 hours in a day, 365 days a year. A light year is 6 trillion miles. So this system, the Trappist system, is 240 trillion miles away. By looking at that star in the transit methodology, so when the planets transit between that star and our observation point, in this case the Spitzer telescope, you can see the brightness of that star drop. And you might be thinking that's not a very precise scientific measurement, but trust me, it is. I'm not going to go through the details, but on the left-hand side, you can see that over a 23-day period, the signature of each planet was very precise, very repeatable, and we could tell that there were planets there, their magnitude, and what their orbital period was. So this is old news as of last February. The reason I'm putting it up now, as we talk about looking to the future, is our understanding of the number of exoplanets I believe is about to explode. And the reason why is this was a 23-day observation. That's as long as Spitzer looked at this star system. Imagine we were there looking back at our star system. In 23 days, how many transits would we see? We'd be lucky if we caught one. Our closest planet, Mercury, orbits the sun every 90 Earth days. So in 23 days, we might catch Mercury, or if we're lucky, we might have just happenstance caught one of the others. But the real message here is, as our capability to stare in the future get longer observational periods, the number of exoplanets is just going to balloon. This is really an exciting area of discovery. I'm getting near the end. I'm not sure how much time trust me, I'm working on it. In heliophysics, next summer, we're going to launch the Parker Solar Probe to explore our sun. On that heat shield on the sun side, 3,000 degrees, room temperature on the backside. The solar is powered by solar rays. They deploy when you're farther away from the sun, retract, obviously, when it's close to the sun. It's going to be within 4 million miles of the sun, flying through the sun's corona. If those of you who are thinking 4 million miles, that's not that close. Well, trust me, it is. The 1 AU, the distance between our sun and the Earth, is 93 million miles. Call it 100 million for just general numbers. We'll be within 4% of the distance between the sun and the Earth with this spacecraft. We're going to collect data that we've never even imagined before. Excitement and exploration is right there, and that'll lead to new discoveries in heliophysics. This is where I give a shout out to NOAA, a shameless plug for our good partners. This is from the Suomi NPP, a VIRS image of Hurricane Maria about to strike Puerto Rico. It was a devastating hurricane. I think we've all heard about that. IR image, and it really tells a story unto itself, so I don't need to elaborate on that. And here's the aftermath. An IR image at night. The first one was pre-Hurricane Maria. On the top of Puerto Rico, you see San Juan. To the west, you see Mayaguez. To the south, Ponce. And then post-hurricane, the devastation and the loss to the power grid. I know the first responders were using this data, overlapping it with local maps to help get to folks in need. So space assets make a huge difference in people's lives. Speaking of making a difference in people's lives, we had an aircraft, a P-3, that was flying out of South America doing laser altimetry in the Antarctic. When the Argentinians had lost contact with their submarine, the San Juan, they asked if NASA could help. Our P-3 is still fitted with magnetometers, and in very short order, we said, absolutely, if there's a need, we'll pitch in. So here's a perspective change for you. Yes, we had a science mission, but we had a tactical mission, a human mission that needed attention, and while we unfortunately did not discover the submarine, our folks were with the Argentinians on site almost immediately. We were the first international folks on site with an asset to help in the search. And finally, this is the overall, I talked a lot about other scientific areas. This is the Earth Science Roadmap. On the bottom half, sweeping up towards the center, pointing at the Earth, are the missions in operations. So you can see the current suite, and in the interest of time, I'm not going to talk to each of them. On the upper end, you see all the missions that are in formulation, or in operating, in implementation, and in formulation. And our Earth Science program is very robust, and I'm very proud of the work that Mike Freilich and his folks are doing with the international community and with our partnership with NOAA. And thank you very much.
Next up, we have William Easterling from the National Science Foundation Geosciences Directorate, and also a test to see if the president knows how to push the right buttons, but we'll work on it here.
Thank you, Eric, and good morning, everybody. Just the first order of business, just a minor correction. I am no longer the Dean of the College of Earth and Mineral Sciences at Penn State, and so if Lee Kump, who is the current Dean, is in the audience, he can rest easy that I'm not back to take his job. And I don't want to serve on any more committees than I have to, so I refer to myself as the immediate past Dean of that college. I have been at NSF now for about 6 months, and so Admiral Gallaudet and I are in a foot race to see who can stay most current appointment as long as we can benefit from that status. NSF, as you know, is an agency that facilitates fundamental science, fundamental research, and so the way I approach my assignment today is not so much to talk about the great things that we're doing, although I take a page from both of my preceding speakers that I probably should have put in some examples of some of the just amazing science that we're doing. But I'm not. I'm going to be a little bit more focused on talking about, I think, some things that you, the community, and virtually all in this room who are researchers should keep in mind. I recognize that I am leading with a topic that's somewhat worrisome, and yet I want to reassure you that there is a happy ending, I think. We are living in a world where we're facing the possibility of budget decreases, certainly at NSF, but broadly across the federal government. And I want, if you take anything away from my talk today, I want you to remember that in spite of the angst and the discussions of budget decreases and what they might mean for research programs, certainly in the geosciences, there is still a tremendous base of resources, of funding available to do important science, no matter the outcome of the budget process. So I thought you would find it useful to see how we in the National Science Foundation approached the possibility, being responsible budget managers, of a substantial reduction in the NSF appropriation. And so I'm just going to run through these very quickly, and I put them there again just to reassure you that we're thinking of these things and that life will continue no matter what. First of all, and these are principles that all of the assistant directors and Director Cordova met and discussed and developed immediately before I arrived. So I inherited these, but I subscribe to them fully. We will, no matter what, continue funding all of the major science and engineering disciplines across the foundation. We see absolutely no case to be made for eliminating or cutting whole programs. We see the merit. We have to continue to make it possible for the new junior cohort of scientists, especially in the geosciences, to be supported, to be given that fair chance to develop their careers, just as many of those who've reached my stage of life had my chance to become a scientist and enjoy the full benefits of a wonderful career. We also, and this is something you need to hear and take home with you and think about, we are committed to protecting our core programs. That is a first principle for us. But I say that and I immediately follow it, that we have an obligation to continue to promote cross-disciplinary research. And you know the programs that I'm referring to, many of you are PIs in those programs, and yet it's a matter of balance. So take that away, that we will continue interdisciplinary, interdirectorate research collaborations. It's just a rebalancing act, and we are not sure how that is to be quantified at this point, but it is a topic of discussion across the agency. And then finally, and this is partly my own personal view, and I have held it as an academic administrator, and I certainly will practice it as the Assistant Director of Geosciences. If we have to make reductions, they will be strategic. I don't believe in across-the-board budget reductions. So these are tough decisions. There probably will be some across-the-board reductions if we reach that point, but there is still a long ways to go in the budget process. So hang on. Nothing is decided yet, and these principles could all be moot. Moving on. I started back in May, or actually June 1st was my first day in the directorate. And for those of you, actually let me back up and just see a show of hands across the audience. How many of you have read the Geosciences Directorate's strategic plan, Dynamic Earth, or at least opened it up to receive guidance? Could I see a show of hands? Well, that's telling. So it is a guiding document that the directorate, its program managers, its program directors often use for making decisions about where to go next. And it's actually a very comprehensive, interesting, and exciting document. It doesn't read like your grandmother and grandfather's strategic plan. It really is extremely well done. But what you need to do is look at it, if you would. I'm imploring you politely to look at the document and think, is it still capturing the excitement and the important new initiatives that we need to be thinking to fund in the immediate future? And Kip Hodges from Arizona State is the chair of the Geosciences Advisory Committee, and he has taken it on himself based on the conversations that I've had with him and the division directors. And just a little sidebar here, Geosciences consists of 4 divisions, or 3 divisions and an office. One is Atmospheric and Geospace Sciences, another is Earth Sciences, a third is Ocean Sciences, and we are also strongly coupled with the Office of Polar Programs. So in conversations with these divisions and offices, we decided that we needed to get your input on how well Dynamic Earth covers the landscape of important research topics for now and for the immediate future. And so I've put up on this slide a website and an email address that I am asking you to respond to. If you look at Dynamic Earth, have ideas, the Geosciences Advisory Committee would greatly appreciate your input. This is your moment. This is a community science moment where you have the opportunity to influence where we begin thinking of the next direction to go in the earth sciences broadly. So, and there's a expiration date of February 1st, we would like to have that input. So please, if you just take a moment, and trust me, it is an interesting document, at least to thumb through. And if you're inspired to do so, please give us your feedback. So let me move from there to what is coming into focus across NSF, and particularly for the Geosciences Directorate. I know many of you have heard reference made to the so-called 10 big ideas at NSF. The origin of those 10 big ideas was a conversation that was held between the National Science Board, which, as many of you I'm sure know, is the governing body of NSF, and the NSF leadership. And the Science Board asked, could you please identify some of the truly grand challenges that science must address over the next decade to 2 decades? And through a mostly internal dialogue, the 10 big ideas began to take shape. And I have them up here. Time precludes my going through each big idea, but I want to assure you that geosciences is fundamentally a part of several ideas. The one that we will be responsible for developing is what is being called navigating the new Arctic. And I want to say a few more words about that, but I also want to mention that, that the Directorate is also threaded throughout several of these other ideas. And when the rollout begins, and that's the punchline, it's coming this year, you will begin to start to see dear colleague letters and announcements of solicitations that will begin to address these big ideas. And we will be connected, for example, to big data, to the life sciences rules of life, and multi-messenger astrophysics. So there's a lot of cross-directorate cooperation in addressing these big ideas. But we will be leading navigating the new Arctic. And you can't talk about the Arctic without seeing at least one slide of that was what it was and this is what it is today. And the slide shows here sea ice cover in 1984, seen from space, and what it is in 2016. And you know, every time I see this, I like many of you, I'm just blown away at how much change is happening there. And so what we are focusing on, first of all, is developing a much deeper understanding of the physical mechanisms that are driving the rapid changes that are happening in the Arctic. And that will require, first and foremost, a robust observational network, both in land, atmosphere, space, and in the oceans. So our first effort, and this is where I want you to listen carefully, we're mindful of the fact that starting a new initiative is difficult at best in a time of budgetary uncertainties. So, as the National Science Board points out time and again to us, well, if these are truly the important challenges, then what's keeping you from starting? What's keeping you from going, even if budgets are not expanding? It's a good question. And so we have a Dear Colleague letter that is due to hit the streets next month that will begin to point the community toward existing solicitations, existing programs that are already funded. They will take no money away from core objectives within the directorates, and that will give us a running, well, let me say, it will be a fast walk start to launching Navigating the New Arctic. So stay tuned for those of you who are interested in what is happening in the Arctic, that letter will be arriving probably around mid to late January. So let me end with a commercial of sorts. I came to the directorate and I inherited division directors that form what I call a dream team. But the problem, well, it's not a problem, the reality of how NSF works is that the leadership rotates frequently, at least most of it does, because we are all on loan from various home institutions to spend our time at NSF working in an absolutely phenomenal environment with very dedicated and talented colleagues who are responsible for shepherding a tremendous asset, the largest funding of fundamental research anywhere in the world. And I will have 3 of those division directors, starting with Earth Sciences, Ocean Sciences comes next, and then finally Atmospheric and Geospace Sciences. Those leaders will be stepping down in the next year. And so I have a point of contact for those of you who feel compelled to either seek this as an opportunity, or you know someone who could step in and possibly take over one of these positions. And the heads of the selection committees are for, and let me just run down the names. Many of you I know these people quite well. Rick Murray, who is the current division director for Ocean Sciences, will be chairing the Earth Science search. Kelly Faulkner, who is the current head of the Office of Polar Programs, which of course organizes all of our Arctic and Antarctic research, will oversee the ocean science search. And finally, my very recent appointee for Deputy Assistant Director of Geosciences, Scott Borg, who had been head of Antarctic programs, will chair the search for Atmospheric and Geospace Sciences. Their emails are on the slide, and I'm more than happy to provide them to you if you email me, if you don't remember them from this slide. So one last mention is, because of Scott's transfer to my office, we will need a new head of Antarctic Sciences programs, and the head for that search is Paul Shepson, and he is listed here with his email address. And let me point out, just in closing, that there will never be a better time to be affiliated with the Antarctic program, because we are in the middle of solidifying our investment in a major overhaul of the McMurdo Station in Antarctica, and we are hopeful that that process will begin in fiscal year 19. So I won't apologize for not showing a lot of exciting science. I feel like I learn something new every time I get in front of a group here as the assistant director. Next time I will have them. But thank you very much for the opportunity.
Thank you. Next, I'd like to show a brief video from USGS. This is from Bill Werkheiser.
Good morning, ladies and gentlemen. I'm Bill Werkheiser, Deputy Director of the United States Geological Survey, and it's a pleasure to speak to you today. Before I get started, let me just take a moment to extend my regrets to you and my fellow members of the panel for not being able to attend the session in person this morning. However, I sincerely appreciate the opportunity to speak to you remotely about the USGS, our priorities, and our way forward as we address some of the most pressing issues facing the nation and its communities. I also don't want to overlook an opportunity to thank the other members of the panel for offering their perspectives as well. Thank you all for your time and insights today. As everyone is already keenly aware, it is an interesting time and dynamic time to be a science agency inside the federal government. Since 1879, the USGS has been the nation's primary federal source of non-regulatory, non-advocacy science on the Earth and its processes. Today, this work supports the economic welfare of the nation, protects the safety and health of our people, and advances understanding of the environment, ecosystems, and species that share our planet. In the 21st century, there are a host of global and national issues that require our attention and concentrated efforts, and the USGS is fully engaged in addressing a variety of these concerns. Through collaboration with our partners in government, academia, industry, and beyond, we bring to bear a range of scientific capabilities to monitor and ensure the availability and quality of the nation's freshwater supply, to improve the nation's ability to prepare for, respond to, mitigate the effects of, and become more resilient to natural hazards, to ensure access to an abundant supply of conventional and alternative domestic energy resources, and to help ensure that they are produced in a way that minimizes impacts on the environment, to ensure access to economically viable domestic sources of minerals such as lithium, specialty metals, and rare earth elements, which are needed for infrastructure development, new technology, and national security, to understand the functions and health of ecosystems, native and invasive species, and wildlife diseases, as well as their effects on human health, and to provide scientific insight and data which helps our partner agencies manage the nation's public lands and their abundant natural resources, and explore how best to adapt to changes in land use and the global climate. These societal issues are among the more enduring opportunities for study and innovation, and they require the full breadth of interdisciplinary expertise the USGS and its partners can bring to bear. We need to integrate and leverage assets, data, and capabilities with our partners as we work together in addressing these societal priorities, as well as answering complex science questions and overcoming grand challenges that require a multidisciplinary approach. One example of such enduring partnerships is our decades-long collaboration with NASA to deliver a sustainable land imaging capacity, building on over 45 years of joint support for the Landsat series of satellites. And we are forging new and extraordinary partnerships between the earth sciences and other scientific disciplines. A great example is our collaboration with public health and medical science communities that work to uncover and capitalize on interdependent relationships that exist between the earth, the environment, its wildlife, and human health. In order to address global and national challenges in the years ahead, there are a number of advancements and capabilities that are required before true progress can be achieved. We need to leverage rapidly evolving technologies such as genetics, environmental DNA, supercomputing, and the development of advanced, smaller, and more capable network sensing devices. We need to enhance Earth observations, both from space and in situ, and improve our capacity to integrate data from stream gauges, seismic networks, satellites, and numerous other monitoring networks to improve the nation's real-time monitoring and forecasting capacity. We need to expand efforts in surveys and mapping that describe the Earth in high resolution, producing maps that are accurate, timely, accessible, and based on community standards. Such efforts include basic geologic mapping, high-resolution surface mapping with LiDAR, and detailed geophysical mapping of the subsurface. The information from this mapping can be used for a broad array of applications, ranging from identification of areas with high mineral and energy resource potential to areas with potential geologic hazards and subsurface groundwater aquifers. Finally, we need to expand our modeling capabilities so that we can more accurately and completely model Earth systems. thereby enhancing the nation's capabilities for forecasting, prediction, early warning, and decision support. The USGS will engage the national and global issues of the future with an unwavering commitment to innovation and collaboration, and we will never settle for easy suppositions or shy away from uncomfortable conclusions. It is an exciting time to be part of the Earth Science enterprise. At the USGS, we know that collaboration is vital to advancing society's fundamental understanding of the Earth and our place on it, and that the AGU Fall Meeting is without a doubt an absolutely essential venue for USGS science. Although the USGS has not been able to participate as fully in the event this year as we have in the past, I hope Fall Meeting participants have been able to get a good idea of the broad range of USGS science through our talks and posters, and especially through interactions with our scientists outside the formal presentation. Thank you again for the opportunity to provide a few brief remarks, and I hope you enjoy the rest of your time at the 2017 AGU Fall Meeting.
So I'd like to invite our panelists up to the stage. I've learned that this room is available to us to go over a little bit. I recognize that many of you probably have sessions to attend at 10:20, but this is a great opportunity, I think, that we can't afford to pass up in terms of offering an opportunity for Q&A. There is a microphone here. I guess that's the only one that I see. So feel free to queue up in front of the microphone if you have some questions for our panelists. While we're waiting for audience members to do that, I'd like to start out to ask each of the panelists, since we had somewhat of a difference in your approaches of two of you showing really cool things that you're doing, that your agencies are doing, and including very articulate linkages between what your agencies are doing and the economic and human health impacts. And then Bill Easterling talking more about the challenges of funding levels and how that will be addressed. So I'm going to give each of you a chance to sort of do the flip side from what you did in your presentation, if you'd like, and talk about, just very briefly, what either, well, for NOAA and NASA, what you view as your challenges for funding coming up and how you intend to address it, and also for Bill to talk about some of the things that he'd like to emphasize. But just try to approach that very briefly, and we'll see if we get some questions from the audience. Would you like to go ahead, Tim?
Sure. Can you hear me? Oh, that works great. So funding challenges, we have several, I would say. Although I promoted our satellite successes this year, in the out years in the President's budget, our Polar Follow-On program, which is our Polar Satellites 3 and 4, the funding levels were reduced in the President's budget. So that'll be a challenge. That might shift the launch readiness dates beyond what we hope for. But the successes of the current constellation, I think, are enough to keep us strong and healthy with respect to space-based observing systems going out into the future. The other concerns we have is some of our coastal programs were reduced, but I think that as we explore and potentially leverage more public-private partnerships and partnerships with our states, that we could fill some of those potential gaps.
Thank you.
Okay. This is on. Sorry, we're not seeing the little green light that tells us that it's actually on, but fortunately it is. At NASA, our biggest concern looking into the future was the potential weather gaps in weather spacecraft that Tim just mentioned. Admiral Gallaudet just mentioned. But we're closing the gap on those. Last November, we launched GOES-R, which is now GOES-16. A couple of weeks ago, we launched JPSS-1, which is NOAA 20. GOES-S was just shipped to the launch site and will be launching in March. So we're seeing progress on those fronts. As far as the proposed budgets going forward, we're kind of in we're looking at what is a flat budget. And I'd like to think flat is the new up. So we're actually well positioned, and we're hoping that it does, that the budget stays that way. We have a robust portfolio of missions that will meet our customers' needs and our scientific needs.
I'm going to kind of mold Eric's challenge to me for NSF to bring up a topic that I know is discussed a lot in the trenches, and it's relevant not only to NSF but really broadly across the agencies, and that's how we navigate through the challenge of continuing to support research, fundamental research, and in some cases applied research. You know, just a side note, I sometimes have a lot of difficulty distinguishing those two. But to support research that sometimes takes on a kind of controversial flavor in the public discourse. And of course, you would immediately think of climate change as being one of those. My experience from my previous job was rather extensive in dealing with many scientific as well as social issues around hydraulic fracturing. These are all very important scientific topics, and I sometimes hear in the conversations I have with colleagues across the country, if not across the globe, concerned that perhaps we are walking back, if you will, from our obligations to fund research in these areas. And I want to assure you, now I'm speaking strictly now as the Geosciences Assistant Director, but I want to assure you that we see not climate change per se, we see how can we best understand how the climate system works. In fact, you could expand that to say how the world works. And I think we practice what we preach there as far as funding research in areas that certainly have relevance to understanding climate change, understanding evolution as it connects to Earth history, how to best understand the fundamental questions of rock mechanics in places that are where hydraulic fracturing is likely as a resource extraction technology. So I know there's been some media coverage of what we should say and shouldn't say when we talk about our science, and again, particularly around climate change. And I will say what I said to the Geo Town Hall the other day, that we will never back away from confronting and funding research that asks and shows the promise through merit review of answering these very difficult questions, no matter what we call it. And so let the record stand that we're in it, and I suspect that my colleagues down the row here would say the same.
Would any of you care to add to that? I'd like to ask another question then about what AGU and its members can do to help you in addressing these challenges, either what we can do as an organization, what individual members can do to show support for the agencies, the importance of the work that they do for our science, and help make your jobs a little easier in terms of acquiring the resources that you think your agencies need.
That's right. Well, thank you. That's a great question, and I have an answer for you. I think my colleague to my right here, Dennis, he's from an organization that probably every single American is widely familiar with, because you guys are pros in terms of what you do and highlighting your importance to the country. Everybody knows NASA. Every child in every school knows about voyages to space. But the work NOAA does is a little bit less well recognized, but it's just as important, and we save thousands of lives every year. We protect property and we empower the national economy. One example would be with our charting and our forecast for weather, and our oceanographic analyses allow for trade of the order of magnitude of about $1.4 trillion every year in and out of U.S. ports. So we contribute significantly to the U.S. economy, the American people, and if you could help advocate for us, certainly among younger people, not only would it hopefully secure a better outlook when in future administrations' budget submissions, but also we need to recruit young, smart people to come behind those who are leaving, and so your help there would be greatly appreciated.
Okay. I'm sure we have a lot of early career scientists who would be very eager to take up your challenge. How can we try to help with that matchmaking process?
And I'd second those words. Getting the word out, and credit to NOAA. When the last hurricane season was upon us, you could not turn on the TV, you could not pick up your phone, you could not power up your computer without seeing an image from GOES.
That's right.
Or from an image from JPSS. It didn't say NOAA on there anywhere normally. It was these are great images. So get the message out. The storytelling and the data visualization challenge again helps accomplish some of those kind of goals. But definitely communicating to our stakeholders and making sure people understand the value of what we get from the aerospace business, space instruments, space assets, and ground-based assets is really key to the success of the overall community.
As I came into NSF, one of my goals was to take head-on the challenge of seizing back, I like to call it, our own narrative of the value of the geosciences, of fundamental research in the geosciences. And it is clear to me that whatever we have been doing as far as convincing the public and in many cases our elected leaders of the value of geosciences research, it hasn't been as effective as it needs to be. And I know we try. And so one bright spot that's directly relevant to this meeting is that in an initial get to know each other meeting with Chris McEntee and AGU staff, we started a conversation about how can we better tell the story of how important it is for the nation to invest in research that may not have any particular immediate application in mind, but has the potential to be revolutionary, both in a scientific sense, but also very importantly in a societal and technological sense. And so we will be looking back into the annals of some of the really important groundbreaking research that has been done in the geosciences, and this is being done now by AGU in preparation for the centennial. And why not take advantage of some of these incredible stories that we know resonate with our friends on the Hill? So this this is something that I would love to join my colleagues in the agencies here and other science-oriented agencies so that we put our best foot forward. It shouldn't necessarily just be fundamental research. It should be how important it is that research moves to operations, which is a process that we don't manage especially well. Now that's my assertion, and I would love to be proved wrong in the 4 years that I'll be with NSF. Thank you.
Thanks. We do have a question from the audience. Please
Hi.
introduce yourself.
Thanks. Ann Nolan, Oregon State University. It's a mix of a question and a comment. So I've heard words like investment, early career, best science, and my comment is, one of the things I haven't heard is, how are you as leaders changing the culture of the agencies so that early career women in science are not just brought into the system, but encouraged and made to feel safe? And, you know, we can tell our stories, and you talked about incredible stories, but I'd like to remind you that there are many credible stories about things that have happened to women in science. And there are those of us like myself, or Robin Bell, Carol Finn, Margaret Lynan. We're the ones that are still here. But the investment that has been lost are all of the women who might have been brought in as early career scientists but have left because of an extremely challenging culture that continues to this day. And I'm so happy and excited to be able to even talk about this in public. It's a big deal. And the conversations that I and many, many other women have been having this week have really been dynamic and exciting. One of the things, though, that I haven't heard on panels such as this, and I'll call it a manel, because it is that these investments are really critical for workforce development and women in the workforce in these key areas. So I'd love to hear what you plan to do.
Sure.
And that was a great question. And I think I could probably spend the whole time talking about what NOAA is doing to advance and promote women in science. And if you happen to be in the DC area tomorrow, I will be speaking at the Women's Aquatic Network of Washington on this very topic. And I think we have really great examples, as you said, of women breaking barriers, at least in the marine and ocean sciences. You mentioned Margaret Lynan possibly, I think, and we have Marcia McNutt at the Academy. And there are many others. There's Cindy Lee Van Dover, who was the first deep-sea submersible pilot, female, and there's a long list. And in the Navy, we have, for example, Rear Admiral Grace Hopper, who was one of the pioneers in computing. So NOAA has many active programs to promote people like them and build upon their legacy. And we had a diversity and inclusion summit and program and strategic plan that we have to foster that. And on the other side, and another aspect of that, we also have Congress passed a NOAA Sexual Assault and Harassment Prevention and Response Act, a law that we are following right now. So I could talk at length, and I would enjoy that with you and others, but we probably don't have the time for that. But I do see it as important, and if you'll allow me indulge me, I have a personal side of this. My wife, I told you in there, my talk was a U.S. Navy diver. She was one of the first female divers in the Navy, and it wasn't easy for her. This was 1990, and there were a lot of men in the Navy who just couldn't accept women taking leadership roles, and so she was a victim of daily sexual harassment from her own commanding officer, and that drove her out of the Navy, and the Navy lost talent because of it. But she allows me to tell her story, and if I could prevent one instance of that ever from happening, it'd be a good thing. And having 3 daughters, I would never want them to have to go through any of that either, and I'd like to see them fulfill their dreams wherever they go, if it's NOAA or any of the organizations represented and advocated for by AGU. So thank you for that. Thank you.
At NASA, we completely agree and understand with the comments you were making, and the data shows that the women in senior PI positions and who are proposing, the percentage is very low. and we are addressing that as we speak. So this is a very timely point to bring up. We within the Science Mission Directorate, Dr. Thomas Zerbuchen and I, are talking to all the center directors. We want to raise the awareness of what the diversity is right now in some of those project management and PI positions. We want to address it and change the culture. As a matter of fact, I missed a meeting this morning on that exact topic. Ellen Gertson, who's here with me today, our Chief of Staff, has been gathering the data to raise awareness. We want to increase the candidate pool of the young women so that they can be proposed on future announcements of opportunity and will be that future generation of PIs. We need to see the ratio change. When I was emboldened, it was very exciting rather, when I walked through the poster sessions. There were a great number. It wasn't 90% males out there. It was. I didn't do an exact count, but I'd say there was at least 40% of the folks at posters were women. That's awesome. If you look at the graduation rates of women out of college at the undergrad level and in the physical sciences, it's about 50%. And folks say, well, maybe that tapers off into the graduate levels. It doesn't. For the last 13 years, it's been about 50% for women in the physical sciences at the undergrad and at the graduate levels. Engineering, it's about 25%. So it's there's a little discrepancy there, but clearly we need to do more to increase the candidate pool for women. We need to encourage them and give them opportunities where they can succeed. And we're in the process of working on that right now and addressing that question as we speak.
So I had many thoughts as I listened to your question. It was very artfully asked, and it made me think back to across my experiences recently as the assistant director at NSF and how we're handling some of these challenges at NSF, and all the way back through my 10 years as dean of an earth sciences college. First of all, let me just simply say flat out that France Cordova, the director of the National Science Foundation, just recently issued a very strongly worded letter that we all in the foundation stand behind that essentially states a zero tolerance for sexual harassment of any kind, but certainly sexual harassment. And so let the record show that. One thing that I thought I knew well after about half of my time as dean was that we were putting a lot of effort into enticing not just women, but all underrepresented groups into the earth sciences. I don't need to lecture you on the difficulties that we have had historically with attracting underrepresented groups to the earth sciences. And I thought that most of the game was how can you recruit people and get them to come to your institution? But what I've learned, and now I try to put into practice in how I manage and how I look to the future for efforts to better improve the diversity of NSF, is that that's only a fraction of the challenge. The real challenge is providing a workplace where women and other minorities, underrepresented groups feel that they are not only fully appreciated, but that they achieve fulfillment in their jobs. And let me tell you, when I started as a dean, we had a survey of the status of women in the college, and I thought we had a pretty good benchmark from which to start. And Kate Freeman, a name that many of you in the audience would recognize, asked me if I would repeat that same study 10 years later, and we did. And I expected that I would read about all these wonderful steps forward that we had taken. And what I learned was that about 80% of the women that we had hired, and we hired a lot in the past 10 years, expressed a very high level of not dissatisfaction, but a feeling that they were underappreciated. in their roles within the college. I see that same situation replicated in the Geosciences Directorate at NSF. And so we have to work hard. And we have to not only do a good job of getting the numbers up, if you will. That's the easy part, really. It's creating a climate in which everyone can succeed and feel good about themselves. Now, we're trying. If you want a program, one of the big challenge ideas, one of the big ideas is what we call includes. And this will be a large investment at NSF in universities and other institutions, not just research institutions across the country, to institutionalize best practices in achieving the kinds of outcomes that I would have liked to have seen in my own college and that any dean would have liked to have seen in theirs. So I think we're confronting it. Progress is not as fast as we would like for it to be, but it's not going away, and I know you and many in this room will make sure that doesn't go away. I think we're starting to get it.
Well, thank you, and I'd like to thank all of the panelists and all of you in the audience for having come and stuck with us this long. And would you please give our panelists another round of applause?